Fine. So once we will have the result, so look at this. So we pass on formula and Jacobian. So we have the derived formula. Well, for the derived formula, we still need to check the range for variable x and, variable u and v. For variable u and v, so we understand x greater than 0, y greater than 0. But why we have the current range for u and v? Remember, we have this x and y. So x and y, we have that range. We have that relationship. So we have this u plus v greater than 0 and u minus v over 2 greater 0. So finally, we have this one, u greater than v and u greater than minus v. So that says u greater than absolute value of v. So that's why we have the result, the range for the two variables. That's on x and y. So x greater than 0, y greater than 0. Based on that, so we have these. And finally, we have x greater than v and x greater than minus v. So put them together, we have the relationship like this. Well, that's our formula. We can reach the right result. We still have the specified range for u and v. So right now, I gotta know how to specify the range for u and v. That's all. Well, again, check it for 1 minute about the range of u and v. Okay? So, the Jacobian here, that is Jacobian with the y. So that's why I don't like the Jacobian on the slide. So the Jacobian here is, I think you can look at the current Jacobian J of x and y. It's not the Jacobian we want to derive. So that's why minus 2 is not the result of ours, minus a half. So the current Jacobian is not a goal for us, no. So how we apply our Jacobian? Sure, and then you have this way to apply the Jacobian. I gotta know, never memorize the form of a Jacobian with a parameter. I just ask you to have this. And this is the so-called Jacobian. And if we have the way to have Jacobian, it should be x perform partial differentiation with respect to zw. And the y perform partial differentiation with respect to zw again. So this one, I don't like to have a Jacobian of x and y or Jacobian of z and w. Actually here, according to the notation of the current slides, it should be Jacobian z and w. If so, then z and w, it should be minus a half. That's correct. But it doesn't mean this form. It's Jacobian of x and y. That's on the current handouts.
How do we apply our result to the formula?
Yeah, this one. This one.
No, the one in the square, the top one.
This is Jacobian. Absolute value of our Jacobian.
Oh, it is the absolute value.
Yeah.
So there is no minus in there.
Yeah, that's correct. Don't forget, we should have the absolute value sign regarding the Jacobian. So look at this. Look at this. So is it okay? So check it again. About the range, is it okay? Okay for you about the range. If everything is okay, I want to specify the right join PDF and the range, because sometimes we are asked to have the further results. What kind of further results? This one. We have a join PDF, but we are asked to have a marginal PDF. Marginal PDF, then we have this relationship. And the marginal PDF, then we have this relationship. Why? If we want to have a U, so we have the integral based on V. So V actually will have the range. How to have the range for V? You can take this to have a range of a V. Therefore, we have a V here. Minus U to U. Therefore, we have the range for the integral. And likewise, if we want to have the result for V based on U, so U actually here greater than absolute value of V and to infinity. So we have the range. Well, if we want to derive marginal PDF, we need to find the range based on the range previously derived. So if you pass on the range here, so you will have U and we have a V and U. If we have range for V here, range of U, so we will have the range from absolute value of V to infinity. And you can derive further. Well, about the setting of the two ranges, everything's okay? Ratio. Okay, and case. V actually you can use this. And U. So you will have range for V and U. Find marginal PDF for U from integral with respect to V. So you need to have range for V. V actually you need to have the integral with respect to U. So U here. So check it again. And everything's okay. Good. And this time, Rufan and Alex. Good. So I asked you to derive further. Right now, but finally we will have to resolve this one. And this one. So we will have to resolve following. That says we can derive marginal PDF. If we have a marginal PDF, this time, if we are asked to have the range, we have a U itself. So what is the real range for U? Real range is 0 and infinity. So this time is 0 and infinity. And the range here for V actually absolute value of V for within in absolute, actually we have a negative infinity to infinity because of absolute value, but remove it, so we will have the entire range, and suddenly we have the whole range for V. Well, that's it. If we have the relationship, you can derive it, but finally, don't forget we have the relaxed range, 0 to infinity for U, the whole range for V. And then that's all for the derivation. Marginal PDF for U and marginal PDF for V. Well, that's it. So this is the formula we apply to get the result. Here previously we have a 2-to-2 mapping to have the joint PDF first. But sometimes you are asked to have the marginal PDF, so you need to have the relationship to divide marginal PDF for you, marginal PDF for me. If we can divide it, then almost done because we have a joint PDFs and we have the marginal PDF as well. Well, that's it. This example is okay. So if you have any questions, just raise your hand and let me know.